BugPicker, a project developed at the Technische Universität Darmstadt. Let's take a quick look at BugPicker. After double-clicking on the jar file, the application is loaded. First, let's set up the project that we want to analyze by going to the File menu and select Load. In this demo, we are going to analyze version 2.3.6 of the open source project Groovy. Groovy is a very good example of a widely used open source project that is developed by multiple persons and which has evolved over several years. In the setup dialog, you can add the project's jar or class files or even directories which contain the project's classes. It is also useful to specify the folder that contains the source code of your project, as it will significantly ease the inspection process. Though not strictly required, it is highly recommended to specify the libraries used by your application. This will increase the accuracy of the analysis and helps to identify more issues. Do not forget to also specify the Java runtime that your project is using. If the project is using the platform's default JRE, you can add it using the button Add JRE. After specifying the project, press Finish to start loading the project. After a couple of seconds, the project is loaded. To make sure that you have loaded the right files, you can go to the File menu and select Project Info to get an overview. In this case, we see that we have loaded 3005 classes. Depending on the size of your project and the available resources, the analysis time differs, but it usually should finish reasonably fast. Now let's start the analysis. Go to Analysis, Run. As soon as the analysis is finished, BugPicker generates a report that points out the most relevant possible flaws in the project's code. Now let's take a look at the issues identified in Groovy's runtime environment. BugPicker identified an issue in the class Variable Scope Visitor in package org codehouse Groovy class gen. The reported issue is that the code in line 520 is never reached, because the condition in line 519 is always true. If you now click on the line number, BugPicker will open the attached source file and scroll to the respective line. In this case, we see that an instance of check is performed in line 519. To fully comprehend the issue, we now scroll to the definition side of the local variable value. In this case, we see that the initial value assigned to the variable is the return value of the function getText. That function always returns string values, which makes the subsequent test useless. Such issues are common in software that has evolved over a long time. Let's take a look at another issue reported by BugPicker. In case of the issue identified in the class MessageSource, BugPicker states that the condition is always null. If we now click on the line number, the source code is opened. As in the previous case, to understand the reason, we now scroll to the definition side of the variable error. Here we see that the initial value assigned to the variable is null. Furthermore, we see that the variable is only updated in line 112, which will, however, never happen, as the guarding condition in line 111 is always false. In this case, the fix is probably to replace the isNotNull test with an isNull test in line 111. Additional issues that BugPicker identifies but considers less relevant or considers to be artifacts created by the compiler are initially not shown. To see those issues, go to the top of the report and move the relevancy slider to the left. You can now see all issues identified by BugPicker. BugPicker can further be adapted to a project's needs by specifying the parameters of the analysis. To do that, go to the Analysis menu and select Preferences. The parameters are documented in BugPicker's help. Go to www.opal-project.de to download BugPicker.